Good morning. I thought I'd start by telling you one bad thing about Erlang. The one bad thing about Erlang is that even bad programmers can program Erlang. Now, it's far better to give a bad programmer a C++, because they never will ever get anything to work. If you use a sort of normal system, it'll segmentation violation or something like that. So the best thing about Erlang is that it's simple. The worst thing is that bad programmers can make worse software works as well, which is a disadvantage. However, who am I? Francesca gave a little bit of an introduction. I've been working with software since 1967. Which I think is probably some time before a lot of you were born. Is that correct? Yeah, it feels funny, doesn't it? Yeah. I started out using Fortran. I went over to program assembly language in C, and I developed the first Erlang virtual machine in competition with my friend Robert Dirty, who is somewhere here today, who invented a machine called the V. I programmed a machine called Jam. It's called Jam because the actual architecture of the machine was invented by Joe Armstrong, who is really the main progenitor of Erlang. So the virtual machine was about sort of 20,000 lines of C, and I became a much more proficient C programmer than I ever have been an Erlang programmer. Writing virtual machines is a difficult art, and Robert's going to talk about virtual machines later today. I then, this was going back now to the 90s, I then got a job trying to sell Erlang. Now, at that time, we thought you could sell programming languages. We came to the conclusion afterwards that selling programming languages is a silly idea. The best thing to do is you give them away free and people use them. If you have to pay money for them, they say, we'll use something else. Well, I didn't sell very many. In fact, I sold one to my friend from Alaska. And he needed I think the main reason he bought it was that he couldn't get a work permit in the United States. By saying that he needed, they were going to implement their system in Erlang, he was the only one around who could do that, and therefore they could guarantee him a work permit to work in Alaska. I don't quite know anyone who wants to work in Alaska anyway, but that's a sort of different question. I gave it a try to sell Erlang, and I worked as manager in Ericsson for about 20 years. I've managed big projects, I've managed small projects. People wonder, why do you need big projects? Just as an aside, that cellular radio systems are actually incredibly complicated systems, and that's what I worked with the last time there. People don't really realize that in the base station and the software around the base station, there are about 7 or 8 million lines of code. And you can't write 7 or 8 million lines of code with 10 people. It's however hard you try. And that's really one of the bases of what I'm going to talk about today. How do you actually organize projects? If you want 2 people, 3 people, you don't really need an organization. As soon as you get above 10 people, you start having to have an organization. That's how people are working. When you have 600 or 700 people working, you need a huge organization, and the efficiency drops. Or efficiency in terms of how many lines of code you can actually get out drops dramatically. I'm now retired from Ericsson. I sort of spend my time walking my dog, which is a nice purpose. My dog has a nice tendency in the evening of wanting to go past the pub. I don't quite understand quite why. Okay, there's some sort of thoughts. Why some software developers, and I call programmers, I tend to call software developers. If you are a program, you think about you're out doing programming all the time. Software development is about sort of 10% programming, and the rest of it is working out what you need to do, configuration management, testing the software, delivering it, maintaining it. You have to remember that programming is a very small part of it. And but nevertheless, some people are a heck of a sight better than others. I think this is well known. I'm sure you all sitting in this room are very good programmers, but I'm sure you also know people who can't program at all. Why do some teams really work? Why are some teams highly productive? And some teams you have to sort of bully and chase every morning and sort of phone and fire their managers and be nasty to them all the time to get anything to happen. Why does it sometimes work and why does it sometimes doesn't? Why are some projects successful and produce software which works and sells and you can get it on and others don't? I think what I'm getting at here is the differences between success and failure and the differences between good programmers and bad programmers is much greater in the field of programming than it is in a lot of other things. Okay, if you're building a house you can have a bad builder, you can have a good builder, but the differences between a good builder and a bad builder are fairly small and you can see it very easily. The differences between a sort of good software person and a bad software are huge, and it's very difficult to see. Why is it you can't run large software projects as a large number of small software projects? Well, I don't have the answer to all these questions, but I have some thoughts which I hope to share with you today. What I've come to the conclusion I've come to over the last 40 years of messing around. Well, one of the problems is recruitment. I took these off, I think I took the advertisements off Monster a few years back. And this is typically the way that companies go about trying to recruit people. They ask for people that they want a C++ developer, or they want someone that knows HTML or JavaScript, or they want someone that knows some other solution technology. Now, this is very strange because it's just like sort of saying to someone, I want someone that can use a circular saw, or I want someone that can use a pickaxe, or something like that. What you want, if you're building a house, is a good builder. You don't want a sort of someone that's good at knows how to use a certain tool. And this is exactly the same as software. You don't want people who know skills such as knowing Java or JavaScript or Erlang or COBOL or whatever you want. You want people that know how to do the job. And this is one of the first mistakes that you see a lot of companies make. They recruit people who know tools, they don't recruit people who know how to program. So this is a lot of rubbish. You should recruit programmers when you recruit programmers who know that you can show that they're productive. It's quite easy to find out someone that is productive. You can actually give them a bit of code and ask them to write it if it's proper writing. You can ask them what have you done before and ask them to show you some old code. It's quite easy to find out whether someone is actually productive in writing code or not. You also have to find someone that sort of says, oh, I don't want to, I'm very good at my job, I don't want to learn anything else. That's rubbish. Technology moves forwards. You want people that are prepared to learn new things. That if you look at what a lot of the minor universities teach, when they teach what they call computer science nowadays, a lot of them actually teach programming languages. They don't actually teach people how to think and what to do. A good programmer has to want to learn new things, and you have to have the right mindset. You have to think it's fun. You don't go into this profession, you don't go into software development simply because it's a way of bringing in money and paying your mortgage on your house. You go into it because you think it's fun. And if you don't think it's fun, please do something else. Well, I started making a list of the ideal programmer. I did this years ago, and I sort of thought that technically competent, experience, understands what technology, not afraid of new technology, understands his own skills and weaknesses, regards criticism and finding of bugs as good fun. They went on and on and on and on and on. And I came to the conclusion, you'll never ever find anyone that meets all these requirements. So what do you want? Well, changing the topic slightly. So someone can distribute these slides later so you can get that URL. There's a very interesting paper produced in, I can't remember which university it was now, but British University, and it was a paper about programmers and what programmers can do and what they can't do. The first thing is there is no correlation in programming with the age, the gender, the educational attainment, or they found that no tests, no normal intelligence test can find whether a person can program or not. Years ago, I worked with people from our HR department in Ericsson who wanted to have a test to see if people could program or not. And we sent a number of our best programmers to psychologists and psychiatrists for deep interviews to try and work out what made them tick, what made them think well. I thought this was good fun. I think the people who went on the test thought it was an absolute disaster. But nevertheless, we sent a lot of people there. And the answer that came back from this, well, they're all reasonably intelligent, and the main characteristic you can say about these people is they're all pig-headed and bloody-minded. That was the sort of main criteria, that they would sort of had their own views. So there's no test. And then the other things about people have ideas about how programs should be written. People, I'll read it again, the Foundation of Computer Science establishment to construct programs top-down, experts build them bottom-up. And that's the way it happens. And that's why all this modelling stuff is a load of crap. It don't work that way. You cannot actually make a model of what you're doing and then transform it into code step by step. The only way of doing it is to try a little bit of it and see if it works, and if it doesn't work, you throw it out. You write another little bit of it and do that. It's a sort of iterative bottom-up, top-down process which goes from one extreme to another. Nevertheless, you'll find lots of books about UML and programming that actually kid you into thinking that it can be done in a sort of rational rational engineering sort of way. And this suits managers very well, because if you're a manager, you like to think this is a nice process and you can predict the end result. It doesn't suit people who are actually trying to do the job, because they know that it's actually a load of rubbish. It doesn't work that way. The majority of good debuggers are good programmers, but not vice versa. That's interesting. You get a lot of good programmers who find it very difficult to debug their code. But find someone that's very good at finding bugs in their code, and you'll find that programmer person is also good at programming. Very strangely, that I used to find in Ericsson that there were two categories of people that tested software. There were categories of people who were actually good programmers, could find bugs, and not only could they find bugs, they could correct them. Then there was a category of people that could find bugs but had no idea why they were a bug or what was going wrong. And the second category of people are always people who are bad programmers, and they've landed up in testing code simply because they couldn't get a job as a programmer. So watch out sorts of testers. If you've got testers, make sure that they can actually write code. And if they can't make code, tell them to go make the coffee or something like that. Then the last one here, I like this one. Programmers on the whole like the point and click, often expect we should make programming point and click, and novices will find it easier. The entire field can be summarized, or they don't. A lot of people think that a lot of tools is what makes a good programmer. If you just give them a good thing, you know, so some use Eclipse or something like that. You can click and you can point and do everything like that. There's actually nothing you can do in Eclipse that you can't do in a good Emacs mode. And you don't need point and click. What you need are the tools which do the job. Being point and click is absolutely a waste of time. I prefer Emacs. It doesn't run my computer that much and it works a lot easier. So there are three types of people. And you know the old joke about the two types of people. There are two types of people. There are those that think there are two types of people and those who don't think there are two types of people. However, I've changed the joke. There are three types of people. There are people who can effortlessly learn to program and don't need any formal education. I'm sure you come across some of these people. I don't know how they work, I don't know how they click, but I don't come into that category. But people that seem to sort of absorb programming and the new languages and new skills and new operating systems and new tools, it seems to come in through the skin, sort of like osmosis. They never need to do anything, it just seems to sort of happen. And then there are people who can be taught to program. You know, quite a lot of those, and but okay, I think I had to be taught to program once upon a time years ago. And good respect, did a good job. Then there's a third category of people. There is a lot of people who haven't a clue what programming is about, or how it works, or how to program. Unfortunately, a lot of these people are in the software industry. But a lot of them never be able to write a significant program. You have to remember that the third category is by far the largest of categories. So remember this. Remember that you have to make sure you get either one or two if you're employing people. And if you're in the industry yourself, you have to think, am I number one or number two? Or am I number three? And if you're number three, do something else. There are far too many people in the software industry. That's why we see today that a lot of companies are sending a lot of their software development to places like China and India, simply because management believes you can't do anything without having thousands of people. If you can't do anything without thousands of people, where do you find thousands of people? You find them in China and India, and they're a lot cheaper than they are in Europe. So software should be developed by a small number of good people. A small number of good people. I have to say that a good programmer is probably, a good software developer is probably 10 times more efficient than a bad one. Okay, if I have 100 people in my team, a normal team, well, if I have 10 good software programmers, they can do the same thing. Well, how do I get 10 software programmers? Well, I pay them twice as much. If I pay them twice as much, and it's going to cost me, I've got a cost gain of a factor 5 anyway. So you can get good software people, but people have to realise, pay good software people a lot, make sure they're motivated, and don't use bad software people. Well, as I mentioned, that I sent a lot of people to a test and we came to no conclusion and all the rest of it. But there's actually a very easy way of finding out people, recruiting people if you have to recruit good programmers. You just give them a bit of code to write. You just give them a simple program that, okay, go away, here's whatever language you write a Sudoku solver or some simple program, go away and do it. And so it's something which they probably haven't done before, and look at about 2 hours later what they've produced. A good program will be able to show you that it works, and bad one won't. It's very, very easy to recruit people. But the majority of companies who recruit people haven't discovered this yet. And it's important that, okay, good programmers do have to have other characteristics. They do have to be able to talk to other people. One of my people I work together with, I won't mention his name because it would embarrass him, is totally incapable of talking to anybody. So he has to have a friend who works together with him to communicate all his requirements. Nevertheless, he's one of the best programmers I know. Strange. But it's good to people that it's good that good programmers, it's good if they don't smell. And it's, there are other social characteristics which are sort of useful. But the main characteristic is to be able to write code, and you can find and test code. You can find that out very, very easily, but very few companies ever know how to bother to do that. Well, the characteristics, a good programmer needs to enjoy programming. They need to want to develop useful applications. You want to find out what the customer needs and deliver it. Whether it's atomic bombs or whether it's whatever it is, they want to find out what does the customer want, not the person on the receiving end of the atomic bomb, the person who's actually developing it. Sometimes customers don't know what they need, and a good programmer has to be able to dig into the file, ask the people, work out, and a good programmer, a good characteristic is being able to find out what people actually want. By no means easy. A good programmer wants to continue being a programmer. Now there's a problem with a lot of large companies. A lot of large companies, the route to money and experience is, and power is to become a manager. So a lot of people, a lot of managers are the bad programmers with ambition who actually filter upwards in the company. Which is why in a lot of companies you'll find that the managers are lousy programmers and don't understand what the people that are working for them are doing, simply because they had ambition, knew they couldn't program, and the easiest thing was to become a manager. So a good programmer has to want to continue being a programmer, not become a manager or a salesman or something like that. He doesn't think it's fun, sorry.
No offense.
Another characteristic of good programmers, he hates interference of a good programmer, he or she will hate interference by someone, by a manager who doesn't understand what they're doing. I used to find in the early days when I worked in Ericsson, I had people managers come to me and say, "How many lines of code have you written today?" And I used to say, "Oh, 200 lines in my system today, the code of that." And they come in and they'd say the next day, "And how many you got today?" And I say, "I got 180. "What?" It's gone backwards. And I said, "Well, I made it simpler." And but managers don't like that sort of talk. They want things to be measured. You can't actually measure productivity in programming. A good programmer, they want to learn new things. There are a lot of new things to learn. That's my dog, by the way. So, he's talking about the new things. Little puppies over there. A programmer wants to learn programming languages, tools, operating systems, application, and most importantly, a good programmer likes making experiments. And a good programmer enjoys when the experiments fail, because they know they've learned something. I can't do it that way. That's another thing to learn. Oh, it went 10 times slower if I did it that way, because my program wasn't hitting the cache or something like that. Failure, experiments which fail are useful, and you have to enjoy making experiments whether they actually work or whether they fail. And a good programmer learns from his or her mistakes. That's what programming is about. It's a trial and error process. You try things out, they don't work. You try things, they do work. So you have to learn both from your successes and your mistakes. Let's say it's a trial and error process. And also, it's a very nasty thing to have to tell management in a large company that the programmers actually don't know what they're doing. They're just testing ideas by trial and error. When you come to think of it, it's all about trial and error. Just you write a bit of code, the first thing you do is you put it into a compiler. Do you spend three hours staring at the code to get away with the syntax errors? Of course you don't. You put it in the compiler. The compiler tells you where the syntax errors are, and then you correct them, and then you run it and find that it crashes. And you say, "Oh, why did it crash?" And I find out where it crashes. It's all the time you're trying things out, things are failing, things are not working, you're going back again. And that is a very important message which is not understood in a lot of these books on software engineering. It's trial and error. That's what programming is about. You'd like to think it is as an engineering discipline. You'd like to think it's all nice and pleasant. It's not. It doesn't work that way. A good programmer likes to spend time testing. Thinks testing's fun. I know a lot of people who sort of say, "Oh, I've written my code, someone else can test it." I don't want people like that ever working for me. It's hopeless. A good programmer likes writing necessary documentation. A lot of big projects have piles and piles of documentation which do nothing except go into the document shredder at the end of the day. You have to think what documentation is important, what will be needed at the end of the project. It needs to be documentation to show why a system is designed in a certain way. You need documentation to show how it works and why it works, and how it can be modified, what the internal data structures are, what they do. A good programmer likes helping others and teaching others, thinks it's fun. Doesn't think that, "Oh, Fred over there, they can't program, oh God, he's coming to my room again." Thinks, "Okay, it's fun. Okay, if Fred can't program, kick him out, but if Fred knows what he's doing, teach him." Because the more friends that are around that are very good at doing something, the easier it'll be. Good programmer likes looking at old code and saying, "Gosh, I wonder when I wrote that, I wonder how it works," maintaining old code. Thinks it's fun. And a good programmer likes adding new features to a system. So actually a lot of that is not actually about writing a system the first time. Writing a system the first time and maintaining a system are two completely separate issues. And a good programmer likes both of them. A good programmer tolerates the fact that capability and knowledge vary hugely between people and programmers. But a good programmer does not tolerate really hopeless people, my category 3 people. Out the door with them. Teams and projects, so I guess you all know what those guys are. There are 3 aspects which are important. You'll find a web reference at the bottom of the URL there, which is useful about a paper about that. You have to have a consistent vision of what you're going to develop. You have to know why you are developing it, and you have to know how you're going to develop it. 3 important things to get any software project to work, or any team to work together. And what? In some cases you have a detailed specification. Not so much fun usually because you can't mess around with it, but sometimes it's necessary. For example, when we made base stations, we had a detailed specification which came from a horrible institution called 3GPP, which described the air interface between the telephones and mobile phones and a base station. But obviously, we couldn't change that specification. Everyone's mobile phone would stop working. People wouldn't like that. Sometimes you get a detailed specification, nothing you can do about it. Sometimes your detailed specification is a standard that you have to follow, as it is in the case with mobile telephony. Sometimes you have a vague idea of what you want. Well, the world would like a new SQL database, so I shall make one. I think you want more companies to do that. Lots of people would like a chat server, so I shall make one. And that's quite good enough, provided you're capable of working out the details yourself. But you have to know what it is, and then you have to know why you're doing it. A vague idea of a multi-function product with lots of bells and whistles is a recipe for disaster. I'll tell you a story which I shouldn't tell you. I've left Ericsson now, so they can't sue me. Disney probably can. But in the 1990s, there was a project in Ericsson to replace the latest AXE exchange with a new one. And the management didn't quite know what they were doing. So they employed about 500 people. I think it came up to 1,000 people in the end. And they put them in a building and they said, design a new system. They didn't tell them what the system was supposed to do. They didn't tell them the system why they needed a new system. So all these people started writing documents and beavering away and working like small dervishes, talking to each other. They developed committees and they developed hierarchies and they developed new operating systems and programming languages and all sorts of things. After the end of about 5 years, having spent over £1 billion, that's a lot of money, isn't it? About £1 billion, the project was discontinued and everyone crept back into their sort of rabbit hutches and started doing other useful things afterwards. Interesting story that, taught me a lot. I wasn't actually involved in it, thank God, but I was watching it from the side, watching what happened. It was actually not reported in the press because it was hushed up. Since it's a long time ago, I don't really worry about it, but it was hushed up and kept quiet. I'll tell you later how it was done, because that was a very interesting hush up. To be motivated, you have to know why you're developing something. Why are you doing what you're doing? You need to see the big picture. You have to think it's useful. Writing software you don't think that's doing anything useful is incredibly demotivating. And a lot of people work in companies when they're developing a little bit of software on the corner of a project. They don't know what it is, why they're doing it. They've just got a specification and just asked to do it. Incredibly one way of demotivating people. You have to sort of see what you're making. You're not making the old story of the man hammering at a bit of stone. And one of them says, well, I'm hammering a bit of stone. Why am I doing that? Oh, I don't know, I've got to make a square bit of stone. The other bloke says, well, okay, why are you hammering a bit of stone? Well, I'm building parts of a great cathedral. You have to motivate people to understand the whole big picture, why you're doing it. And if you know you're doing it something useful and you think it's a good thing to do, people will be happy and work well. Now, how is an important thing. Now, how is where you get down to technology. There must be a strategy for how the whole of your product fits together. Now, you can't have a product with lots of people making various parts all in different technologies. You have to have it fitting together. You can use different technologies for different parts. Okay, that's fine. You should motivate why you do that. We use different technologies in Ericsson for making, for example, our control systems on our baseband processing. There's no way we could use Erlang for baseband processing because that's using programming DSPs and doing things where we could have to do through gigabytes per second through the system. No way we could do that. But on the other hand, we can use Erlang for other things, which are more sensible. You have to know how it all fits together. You have to know how the parts written in one language operates with another part. There must be a reason for the choice of technology. The reason can't be we're doing it this way because the management told us. That's a lousy reason. You're doing it this way because it seems sensible, and you have to show people why it seems sensible. You have to use technology that people feel is right. that you feel this is right, this is correct, this is good, this is the way we're doing it. There's a lot of times I've seen people using UML modeling tools, and they know this is a load of crap, and they know that it shouldn't work. But on the other hand, they've been told to do this by their managers, and they're doing this. And do you think those people are motivated? Do you think those people write good code? No, they don't. They just write code and they go home to their wife and kids and beat their wives in the evening because they're so they get their certification. Well, I don't know. There probably other reasons for that sort of thing as well. But you also have to know that if you're using this software, the result has to be elegant. It has to be nice. There's I don't know whether you've seen him on the net. He writes a lot on some of the Erlang lists called Richard O'Keefe. Richard has he's a weird bloke who lives in it's a nice bloke who lives in New Zealand, and he has a slogan: "Excellence is not optional." Sorry, elegance is not optional. Very true. You have to write good code. It has to look nice. Teams. Well, since we don't have ideal programmers, a software development team has to have a lot of people. And I'm trying to sort of go through who the team. That's the rugby union. You should see, I just had a picture of the All Blacks, and they've got rugby. I was rather into rugby. If you look at me closely, you'll see why I hate Agile programming. I hate Agile programming because I'm missing a tooth this side. And I'm missing a tooth that side because I got it kicked out when I was playing rugby. And I got kicked out in a scrum, which is why I hate Agile programming. You have to have a team. You have to have a team which is organised sensibly. Get enough.
You lost the mic.
Sorry?
The mic.
No. Mike's lost the mic. Seems to be working, I think, yeah? No?
Sorry.
Oh well, that's all fit. I'll shout louder. I'll shout loud, you can all hear me in the back anyway, yeah? But you have to organise a team in a sensible way. You do not organise a team by having a crowd of systems people, a crowd of programmers, a crowd of debuggers. That's the wrong way to organise a team. You have to have the right people. I talked about Agile, but good programmers have been working in an Agile fashion a long, long time before the word Agile was invented. That a lot of this Scrum, extreme programming, Kanban, all the rest of it, clean room, all the rest, they're talking about a lot of this was Scrum Masters, backlog sprints, and they're okay. I don't mind that sort of stuff really, it works. You can organise things that way, but let's face it, there's far too much religion in this Agile business. Good programmers organise themselves properly without having to have a textbook telling them how to do it. They know how to do it instinctively all by themselves. There are plenty of good examples of good technically competent people making software in an Agile fashion who've never read a book about Agile programming or Scrum. It works. So who do you need in a team? First you need a guru. And the most important thing about the guru is he should know what, or he or she, I try to be so completely correct when I say these things, but says looking at the room, I regret there are very few she's here and more he's. That's the way it is, I'm sorry about that. It's a nasty fact about software which I think we should do something about. That each program needs a guru. The main thing about the guru is the guru should be able to understand the application, understand what needs to be done. You should be able to go to the guru and say, how does this work? The guru must be the person that defines the overall architecture. You should maybe have one guru, maybe you can have two gurus in a project. You shouldn't have many of them. You have someone that understands the whole big picture. The guru needs to be explain to other people how the system works, the details. The guru has to be a programmer. I've seen a lot of people who think that they're software architects and can't program. Dreadful. Recipe for disaster. Now, the guru has to be a person that's inquisitive, who doesn't know the answer to a question, knows who to go to ask, how to get the, who to ask, finds out the answer, and next time they ask the same question will be able to answer it themselves. You need an all-round experimenter. You need someone that can jump into the system anywhere and correct things and get things working. You need to be able to work with different software technologies, The experimenter has to be able to do anything. The person that you say, when a really disaster occurs and something's gone wrong with the customer, the experimenter can jump in and do something there. When you're developing something and you're getting nowhere, you push in the experimenter and he works out what to do. The experimenter has to be interested in simplicity and excellence, making the system simpler. He has to be interested in the performance, measuring the system to see why it goes slowly and what to do about it. User-friendliness is an important characteristic to experiment with, to get it better. Development efficiency. We always tend to forget about that, but making the system so it's easier to develop, easier to maintain. This is what the experimenter's job. Going around, not actually being assigned to any part of the system, but going around, messing around various bits of it. You have to have someone who's, look at the last bullet there, has to maintain, someone who maintains the what, why, how spirit of the project. Someone that can actually sort of bring enthusiasm, make sure that these aspects are actually thought about and not forgotten about. Has a plan for how the various parts. You can't do anything without a project plan. You have to have a project plan, but you have to have a very, very flexible project plan. And you have to have someone that can actually do that. The person that's doing this again is a hard programmer. You have to make sure that people who actually run projects actually know how to program. There's an awful profession in large companies of project managers. And project managers, again, are people that escape from programming because they don't like it, can't do it, and decide they become project managers instead. This is completely the wrong sort of person to have as a project manager. Mechanic. Well, you have to have an infrastructure around your software. You have to have a build system. You have to have a system where a test system. You have to have version control. You have to have a delivery system. You need mails and wikis and other communications. You need bug handling systems. You have to have a mechanic to make sure the whole infrastructure, the whole tools infrastructure actually works and the whole build system actually works. Keep it running, grease the wheels, oil the wheels, find things which goes wrong. These people are usually deeply into operating systems and can write new drivers if they need to, and but nevertheless they're people that can sort of equally program, send mail, config files, or equally sort of go into a configuration management system, or equally go into a debug system, keep it running. They don't actually do the job, but they grease the wheels and make sure it works for other people. And of course these people have to be programmers as well. The super tester, you really have to have someone who's really sadistic and really thinks that testing is sort of, I'll find the bugs in this system, I'll show them what's wrong, and can work out all the peculiar things that can happen when a system goes wrong. The super tester has to be able to explain the faults that they found. Can't just say, I did this and it didn't work. Has to be able to go to people responsible for that part of the system and say, I did this, it doesn't work, and I suggest you change this and this to make it work. Has to understand what's going on. There has to be someone who actually checks that coverage analysis is being done on the testing, that all the code is actually tested. There are no big gaps, there are nothing which is left untested at the end of the way. And it can go and help. This sort of person has to be a very helpful sort of person. I call them a sadist, is not really a sadist. This person has to be a very friendly person who can comfort people and say, there, I know it didn't work, but I'm sure you can fix it. You have to have a librarian and an integrator. Sometimes the same person as the mechanic in a small project. Maintains the overall version control strategy, checks things are checked incorrectly, makes sure that the whole system is actually ticking away. The system, the software is actually being put into a good configuration management system, whether it's Git or whatever it is, it doesn't really matter as long as you've got one. And maintains the test build delivery system that anyone can produce a complete delivery system by pressing a button when needed. You need this quite often the same as the mechanic. Documentator. The person making the documents who has to understand the application nearly as well as the guru, can write the manuals and needs to understand what needs to be documented and what doesn't need to be documented, can write user-friendly manuals, and understand the needs of the people that write the documentation. I've seen time and time again manuals written by people that assume that everyone understands the system completely, or I've seen manuals written that are so simple that it excludes all the detail that are needed. Documentation is needed. And documenter has to be able to write clearly in the language that they're using, usually English, but it can be something else. And documenter has to be a programmer. You have to know, the programmer has to be able, if needed, to work out when something is unclear. The documenter has to be able to read the code, understand it, and they can say, ah, that's how it worked, that's what I'll write. Because quite often people program things because there wasn't a specification at that time, and then the feature they programmed remains completely undocumented because no one understands how it works. The documenter has to be able to understand it. And then, of course, at the end of the day, you have the madmen. These are the programmers. You have to be mad to program. You have to be mad. I mean, anyone that works and spends their days in a totally trial and error fashion has to be mad. There's no other explanation for it. And a good programmer should be able to turn their hand to any aspect of software development. And a good programmer is an individualist. I see from time to time that, especially in big companies, the need of putting people in huge open plan offices and think that it works. A good programmer has to be able to shut themselves into a quiet room, work by themselves for some time, come out of their shell, and then tell other people how it worked. That an individualist is an actual characteristic of a good programmer. Well, the question you need to ask is that at the end of the day, you have to have a process. You have to know how is the system being developed. You have to know how requirements are found, you have to know how they're broken down system architecture. You have to know parts of the application program, you have to know parts are tested, you know how it's built, how it's delivered, how it's maintained, how version control is done. If you don't have a process and you don't understand, it doesn't have to be written down, but it has to be completely understood. If you don't have the process, you're in trouble. You have to know how everything works when you develop software. On the other hand, if you believe that you have a process and you've done the process and you don't need any sort of clever people, they just have to follow the process and the result will come out, then you're in deeper trouble. That if you believe that you always have to follow the process, you're in deep trouble. But you have to know there is a process and there is a way which is going to work at the end of the day. There's a good paper by David Parnas, the chap that destroyed the Star Wars initiative in America, about that. It's a rational design process, how and why to fake it. Good paper, I recommend you read that because it actually explains a little bit about processes. Now, I've talked a bit now, I haven't mentioned much about Erlang, and that's what you all came over to hear. But so I'm going to say a little bit about Erlang before I finish, a little bit of my experiences. But before I do that, just remember these 4 buzzwords as far as software development. You have to know what you're going to develop, you have to know why you're developing it, you have to know how you're developing it, and you have to know who is going to develop it. You have the competent people, you have to know what you're developing, the product area, who the customers are, and what technology you use. Those are the 4 buzzwords for success in this area. And we have management tends to concentrate on what and why. Programmers tend to concentrate on how. And individuals at HR tend to concentrate on who, and usually succeed in recruiting completely the wrong people. So what's Erlang good for? Okay, so now, a lot of things. I'm sure you've seen all these buzzwords before, and I'm sure that concurrency, distribution, compact and clear code. Well, that's fairly obvious. Error recovery handled separately from do the job code. That's also important, which is not true for very many other applications. Easy debugging. Lots of ready-made stuff available. And fast turnaround times. Fast turnaround times is actually one of the most important aspects. Now, one of the things we did when we invented Erlang, one of the requirements we had was to be able to change code on the fly. And that was because in a lot of the equipment in telephony, you can't take down the system to upgrade it to correct errors. But it actually had a side effect which I never thought of at the time. It had a side effect, it makes building and testing a lot faster. It means that when you actually have developed something and you're testing it and you want to correct something, you can actually load new code into the system you're testing without having to build a complete system. And that is a tremendous advantage. that in some respects that's one of the best things about Erlang. You can actually load code into a system and test it, and you don't have to restart the system. You have 0 build times. And I think that's fairly unique. That's quite often forgotten. The other thing which I think is, and to my mind is very important, is it's very easy to learn Erlang. I apologise for the syntax. But once you've got past the syntax, it's actually a very simple language. It's a lot simpler than C++ or Java or something like that, and it's a lot more powerful. But simplicity is useful. But as I say, apologies for the syntax. So, communicative, concurrent, distributed, soft real-time systems. And remember, it's not good for everything. Don't try and program DSPs in Erlang, bad idea. I know there's some people working in that sort of area, maybe they'll get someone, but today don't try and do it. It's also iterative. That you can test ideas by prototyping, you can get prototyping, you can get things fast in there. That's one of the real advantages. And we get back to the sort of trial and error. Test your ideas, find out how it works, find out if it's okay. If it doesn't work, scrap it, do something new. Testing, going around fast. 0 build times, finding bugs fast. Erlang fits the bill very well. And this is really what it's all about. It's about the speed of development. The faster you can test your ideas, the quicker you'll get your product onto the profitable market. Getting there first is more important than anything else in this background. It's actually more important to get us there first than having a full-featured system. It's actually more important to get there first than having a system which is completely free from bugs. Getting your system out onto the market before anyone else does is more important than any other aspect, because it's the first person that defines the market, the first person sets the prices, and the first person that makes the profit. Remember that speed is what we make money from, and speed is what you can make money from in software. It's not making wonderful super product, it's being there before anybody else is there. That's where the money is. And since we all want money, I suppose, I think we all do, I hope so. And since we all want money, that's what it's all about. Well, that's what I have to say today. That wasn't much about Erlang. I added a bit at the end because I thought there was little about Erlang. You all came to listen about Erlang, so I hope you don't mind about that in the end. But, okay. Any questions or? Collar me over coffee afterwards. Yeah.
Why did you become a manager?
Well, actually, it's a very long story. That it was a complete accident. I'll tell the story very, very briefly. That when we first started selling Erlang, we all trying to sell Erlang. We started a company called Erlang Systems Aktiebolag. Aktiebolag means limited in Swedish. And we employed a complete psychopath who was the manager of the company. Not only was a psychopath, he was a bit strange. That he firstly employed his wife, and then he employed all his kids, and then he started buying big cars, and large offices and furniture and all the rest of it. And the higher management above me, I wasn't the manager then, decided that they had to fire this guy. And it was a very good thing to do. And they were going to sort of discontinue the company. And they sort of said, oh, well, maybe we should discontinue the company. Well, that's it, sorry lads. And they said, well, can't we do anything about it? So, well, we have to find someone to take it over and to run it afterwards. And I said, well, I might have a try for a few weeks. Well, that's how it happened.
Excellent. Okay. Well, thank you very much, Mike.